In today's video, we're going to take a look at what power is, and see how we can calculate it. Now, although they both mean pretty much the same thing, it's important to know that there are actually two different definitions for power, each with their own equation. One is that power is the rate at which energy is transferred, which can be shown by the equation power equals energy transferred divided by the time it took to transfer that energy. The other definition is that power is the rate at which work is done, and this can be written as power equals work done over time. Now, the term work done can be a bit confusing, but basically it's just a special measure of the energy transferred, and is used when a force is used to move an object by a certain distance. For example, if you pushed a car down the road, then the energy that was required would be referred to as the work done, as you moved it a certain distance. Whereas if electrical energy was transferred from a plug socket to your phone, we would refer to that as just energy transferred, as there's no force or movement involved. In both cases though, power is measured in watts, energy transferred and work done are measured in joules, and time is measured in seconds. To see how the equations work, let's compare two lamps, to see which of the two is most powerful. The lamp on the left transfers 1200 joules over 20 seconds, while the other one uses 1500 joules over 30 seconds. In this case, we'd be using the energy transferred version of the power equation, as there's no work being done. For the left lamp, we'd do 1200 joules divided by 20 seconds, to give us 60 watts as the power. And for the right lamp, we'd divide 1500 joules by 30 seconds to give 50 watts. So we can tell that the left lamp is more powerful. If you look on your lamp at home, there may well be a label telling you its power. Let's now try a slightly harder example. If an 1100 watt microwave is on for 3 minutes, how much energy is transferred? First, we need to take our energy transferred equation and rearrange it to get energy transferred by itself. If we put the equation into a formula triangle like this, we can see that energy transferred would be equal to power times time. We also need to change our 3 minutes to 180 seconds by multiplying it by 60. And finally, we can substitute our values into the equation and do 1100 times 180 to give us 198,000 joules. And whenever we have a big number like this, we can convert it to kilojoules by dividing it by 1000. So we would have 198 kilojoules as our answer. As a last example, imagine that to push a car down the street, you have to do 9 kilojoules of work over the course of 20 seconds. How much power were you using? Once we have the equation, we can see that all we have to do is divide the work done, which is 9 kilojoules, or 9,000 joules, by the time taken of 20 seconds. So the power would be 450 watts.